All right, so my clock is now reading 4:02, and I think that's a good place for us to start. So welcome in everyone to the Technology Happy Hour. My name is Sarah Salkov-Jones, and I'm a program coordinator here with Virginia Clean Cities. Today we'll be hearing from Chas Mease with the Lonestar Specialty Vehicles team. Chas has 12 years of experience in the heavy-duty transportation industry, previously 9 years experience in LTL fleet management, and Chas's current role with Lonestar Specialty Vehicles is North American sales and fleet implementation. I think we are good to go. So Chas, I will go ahead and hand the floor over to you. You can pull up your presentation, and while Chas is getting that ready, I'll just remind everyone again, we like to keep this as an open discussion. So if you have any questions, feel free to unmute yourself. You can use the little hand raise function. You can put your questions in the chat. We'll take them during the presentation, and then we'll also have a space for discussion at the end as well. Just feel free to interrupt. And Chas, I'll hand it over to you.
All right. And is my audio still going?
Yes, you are good to go.
All right. Excellent. I muted there for a second, the struggles of working from home when you have two dogs. So figured you guys didn't need to hear that. Well, we definitely have quite I would say, a great representation from the folks at Virginia Clean Cities and other organizations. And I'm excited to be able to give you kind of a rundown about who we are, the vehicles that we're building, and hopefully this is educational. At any time, feel free to ask questions. This is an exciting time. We were just at ACT Expo a couple months ago in Long Beach, California. Of course, it was canceled in 2020. And it was really amazing for us to see the amount of vehicles that were commercial ready just in the last 2 years in the heavy duty industry. Of course, passenger car and light duty, have been very popular, but the Class 8 market particularly has been a little more difficult for entry. So like I said, at any point, feel free to stop me, ask questions, keep this pretty casual and informative. I'm kind of just going to jump ahead and talk about who we are. So Lonestar Specialty Vehicles, our parent company is TNTX Truck. We are a Daimler Trucks dealership group. We're the second largest in North America. We have 24 full service dealerships across the country. We're a traditional Freightliner, Western Star, heavy duty truck and trailer dealership group. So we service vehicles, sell them, sell parts, etc. The way that we came to be, or the way that we got started, we were actually founded in 2014. We didn't start out right away with electric vehicles. We started assembling glider kits. For those of you who don't know what a glider kit is, it's essentially a rolling chassis. It's a truck that's just the cab and the frame. And so what we would do is we would be the final assembler. We would install the engine, transmission, axles, and then distribute them through our dealership. The reason that we did that was customers were having a lot of issues with the new emissions equipment requirements. The maintenance costs were much more expensive once we got diesel particulate filters on vehicles. And so we wanted to come up with a solution that we could provide a customer with a lower maintenance cost vehicle. That's also how we got into terminal tractors or yard tractors. So those of you who may not be familiar with what a yard tractor is, there's probably about a dozen different names for them: yard jockey, yard goat, hostler. In Canada, they call them a shunt, but they're all the same. I think probably the international term would probably be terminal tractor. But we started remanufacturing terminal tractors for the same reason. Became a requirement for emissions equipment to be on terminal tractors. They are a very high idle time application. And the reason for that being is these vehicles primarily operate at distribution centers. Think about your Amazon distributions, your food distribution centers, where the driver is pulling trailers away from the dock and staging it for a driver to come in that's maybe an over-the-road driver and come in and take it later, or they're putting a loaded trailer against the dock to be unloaded, or another empty to be loaded. So each time that the driver hooks up to that trailer, they have to put the parking brake on, they have to get out of the truck, attach the airlines, remove the wheel chalk, possibly close or open a door. And it's a minute or two process every time. So in a diesel application, that diesel engine's still running, it's still wear and tear, and it causes a lot of issues with that diesel particulate filter. In both cases, we knew that technology would advance, regulations may get rid of that side of the business. So we started to look at other options. At that time, we had been getting all of our axles from Dana. Those of you who may be into off-roading probably know Dana very well for their axles and Jeeps and other off-roading vehicles. But what they did over the last 3 years or so is they started to acquire multiple technology companies and integration companies so that they could build their own electric vehicle platform. So from the traction motor to the power electronics, all the high voltage components, batteries, it's a fully vertically integrated system, you could call it. They have a complete offering. So we started that in 2019. This is kind of the timeline that I just went through. But 2019 was when we started the partnership with Dana and building our first electric terminal tractor. We started in March or April, and we delivered the first one to HEB Grocers. They're a big grocery store chain down in Texas. We delivered one to them in San Antonio, and we used that as a prototype and validation truck. It ran until July, so it got to see some different temperatures, put on a lot of hours. This is an application, think about it like a boat or any other off-road application where they're really not putting on miles. So we measure everything in hours. We did all the engineering work and put things in place so that we could go into full production in 2020. Many of the business, the various departments and things like that at our suppliers were deemed not essential. So just like everybody, our supply chain was choked. But we used 2020 as a year for validation. So we got FMVSS testing done. We did other validation testing at a test track that Dana has, and then came into 2021 ready to go. So we went in full production in 2021. We have about 60 trucks that are deployed, real world application running every day. And we're busy filling orders to date too. So we're really excited for what the next year or two is going to bring, especially with a lot of the money that's going to be available for the next couple of years for this. So when we talk to customers, and I think about this from coming from a fleet background, this pyramid could look different for everybody, but I would say probably 95% of customers, the very first thing is that this has to make economical sense for it to work. So there has to be a payback at some point in the life of the asset. There are few that are strictly sustainability goals, that they've put in corporate sustainability goals that they have to meet. And in order to do that, they have to purchase zero emissions equipment. And then lastly, it could be regulatory. See a lot of information coming out of California with the Port of Long Beach and Port of LA, on when they need to have zero emission cargo handling equipment. And it's a very aggressive goal for them to put in place. So this pyramid could get shuffled around. Sometimes it could be, all three factors coming into play on why someone would go with an electric terminal tractor versus a diesel. There's certainly a little more complexity to purchasing an electric truck versus, prior buying a diesel. So the circle that's there in the middle, those are the things that you have to think about as far as the vehicle side. You have to look at how many hours a day are you going to run the truck? When do you have opportunities to charge, such as lunch breaks, shift changes, things of that nature. And as I mentioned earlier, is based on the amount of hours you're going to run it, when are you going to see that ROI and DCO on the vehicle? But then there's other outside factors. the technicians that have been working on the diesel trucks, they've worked on diesel trucks the majority of their career, and now we're putting a new drivetrain in that they need training on. Our trucks run at 7 volts, so if it's not done safely, you can get hurt. So these are all these factors that we look at. This is most of what my role entails, as far as technician training, operator training, even as far as on the left hand side there, doing infrastructure analysis, especially for large projects, working with utilities, and figuring out what size charging station is going to be adequate for the amount of hours that they have to operate the vehicle. So when we talked about return on investment, right? So this is a simple return on investment model that we use. The one that we typically plug these numbers into would be in more of an Excel format, but this is a lot more of a visual for a presentation. But you can see how we derive these numbers based on the variables on the left. So let's say that we have a distribution center that needs to run the truck 16 hours a day. They operate 350 days a year. That comes to total annual hours of 5,600 per year. Factor in the maintenance cost per hour, which that would be on the diesel side. So for every hour that they need to operate that vehicle, it's going to cost them $3.50 in maintenance because of the preventative maintenance that needs to be done and all the unscheduled repairs that happen. Fuel price that they're paying for diesel, and then the electricity price. And once you factor those numbers in based on total annual hours and things of that nature, you can see that the electric savings, and these are, while they're numbers for for a presentation, they're still very real numbers based on research we've done and third-party research through consulting. So the payback, if you were to look at the cost of a diesel versus what our truck costs, you'd have a 3-year payback. After that, you'll see savings year after year. Typically, if you're wondering, well, how long do these vehicles typically stay in operation? I would say that 10 years is pretty common. So a 3-year payback is pretty favorable. So for some of you who may be into looking at data on performance, we've gotten a lot of data off our fleet. The consumption rates vary based on weights of the trailers, how heavy the load is, average yard speed, how fast they're going, and driver behavior. Are they utilizing the regenerative braking as much as they can, or are they constantly going throttle back to the brake because that's what they were used to in the diesels? But you can see that the kilowatt hour consumption per hour averages out between 6 and 7 per hour. So when you think about it from an internal combustion engine standpoint, think about as far as how many gallons of diesel fuel did you burn per hour. It'd be the same. This is how we measure that. So as I mentioned before, this is a pretty high idle time application because they do have to hook up to trailers and unhook them. So the blue line represents energy efficiency when the truck is in motion. And you can see the consumption rate is higher. The orange is when the truck is essentially idle, when that driver would be hooking up their airlines. And you can see the consumption rates are pretty low. At the time when they're idling, there is no wear and tear on our vehicle. The engine isn't running. And the only thing that is running through this system is coolant to keep the high voltage components at optimal temperature. The driver may have air conditioning on or heat on, but you can see it's pretty minimal as far as a consumption rate when the driver's idle. So then you get a baseline average of, well, I operated the truck for 10 hours today. Let's say 6 hours was actually in drive mode, 4 hours was actually in that stopped mode, and then that would be my baseline or average for the day. That's how we figure out how long the truck is going to last in any application and how large of a charger they're going to need. All right, I'm going to stop right here before I'm going to go start getting into specs and the major components. So I figure I'll stop here, Sarah, and see if anyone has any questions.
Yeah, awesome. I'll just flag one that came through the chat. Dave Gilman was asking if they could get copies of the presentation.
Absolutely.
If it's all right with you. Oh, awesome. I will send it out to everyone when I send out the video recording. So as long as you were registered for the event, it will show up in your email in a couple of days.
Yep, absolutely. And my contact information is on the last slide. So if you have any other questions, if you don't feel like asking today, feel free to call me or reach out to me. All right.
If anyone has any questions, feel free to unmute right now.
Okay. Quick question if nobody else has one. Yeah. Okay, yeah, I'll jump in. Thanks, and that was helpful. But before we get too far, I saw the previous slide with the cost comparisons and savings and everything. But if you know, and maybe you're getting to this, but when clients get these tractors, do you know that they typically work with the utility to alter the utility's rate? You know, to pay a different rate. Have you heard anything about that?
Typically on a larger scale project, they do. We're working with an automotive supplier right now that they're looking at deploying 40 of these trucks at one location. So that not only from an upgrade standpoint, but also as far as negotiating better rates. When it's a 1 or 2 vehicle, I encourage it, but it doesn't always happen. So I would say sometimes.
That makes sense. Thanks.
Could you repeat what the average idle time was? What percentage?
Yeah, we see typically it's about 50% in most applications. I've seen it as high as 66%, and I've seen it as low as in the 30s. It really depends on the application, on, you know, if they're you know, it varies even in applications sometimes too. You could have an LTL carrier, like think about, say, FedEx Freight, for example. They could have one facility that their average idle time is maybe 50%, and they could have another facility, because of the size or how busy they are, maybe there's a 60% idle time.
Have you guys looked at done any analysis on what impact the idle time has on the savings? Is most of the savings gotten, in other words, what's the savings idle time versus diesel versus movement versus diesel? I'm just curious, because you look at it like a transit bus application, idle time, or any kind of heavy duty application, a lot of times there is a fair amount of percentage of idle time. So I'm curious as to where most of the savings are, so you can get some kind of idea that as idle time goes up, savings drastically increase, or it's not that much different.
I would say I can't answer that question with a lot of confidence, to be honest. In this application, when the diesels are idling, you know, they're still burning fuel. So I think you could look at it from that perspective, from a consumption rate of electricity kilowatt hours to the diesel fuel, a lot of kWh, you know, when we're idle. I think that's where that would probably come into play most. You're obviously going to have more wear and tear on the engine, on the diesel engine too. The more you're idling it, more DPF issues, so your maintenance costs would go up. So I think I would say, I don't have specific numbers, but I would say the higher idle time applications would probably see a higher savings.
Great, thank you.
It's Dave Gelman. I'm actually thinking that last point is one that I think people don't emphasize enough of the time, which is the whole thing about the DPF problem. Especially when you're talking about a yard tractor that really is never going much over idle to begin with. I mean, I would think there'd be a pretty heavy penalty on a diesel due to regeneration needs for the DPF. Is that a safe assumption?
Yeah.
Okay.
Yes.
Yeah,
I
I
was
had a
just
feeling
in,
that, I mean, is it still in the order of like a 5% fuel penalty for regeneration or worse than that, or?
what's most common is the DPF and the emission system has problems. So you get clogged
Mhm.
DPF filters. So I was just in Alabama 2 weeks ago, setting up a demonstration vehicle with a customer, and that was the first thing. All three technicians I talked to and their shop manager, they said the trucks they have over there that have DPFs and DEF fluid, they're constantly over here. They're
Mhm.
in the shop, it seems like, just as much as they're over there put to work. And those diesel particulate filters aren't cheap either. They can be up to a couple $1,000s to replace them.
Yeah, I know
And
when WMATA started getting DPFs on their transit buses because the transit buses weren't, regenerating enough and whatever, they were clogging fast. They were having to replace them at twice the rate they were proposed to replace them at, and those were $7,500 units at that time.
Yeah.
So yeah,
Well, and what I think the savings number that I show, I typically talk to customers because it's harder to quantify what I'm about to say. But because of the high downtime on the trucks due to the DPF issues, most fleets need to have additional assets on hand because
Hmm,
they
okay.
the more downtime you have, you're not going to have that truck. And now I need to have an additional $125,000 asset on hand as a spare, essentially.
So,
And
so unlike in a lot of other sectors where we're being told that they can't replace a diesel one for one with an electric, they have to have more than one electric to replace it. This is actually the opposite, where you almost have to have more diesels to replace the same function as you do an electric, which again is another important factor that I think most people don't think about. The O&M, well, the maintenance savings that you were talking about on a yearly basis, is that roughly including like probably also one DPF per year? I mean,
it's
is that the kind of,
including, yeah, it's
life
including,
cycle they get?
yeah, it's including scheduled and unscheduled maintenance. Really, what it comes down to, the first thing with preventative maintenance is most diesel yard tractors are on a 500-hour schedule. So they have an hour meter, just like an odometer. At 500 hours, they go in for a PM. Our truck, because when we're idling, we're not doing any wear and tear on the vehicle. We measure it 500 hours of drive mode. So if you're a 50% idle time application, and on your diesels, you're going into a shop, say every 2 months for a PM. Now you're going in with our truck every 4 months. So the truck not only you're going to see a cost savings because you're doing less preventive maintenance work on it, but also the preventive maintenance on our vehicles. You don't have an engine, you don't have engine oil, you don't have fuel filters, you don't have all that other stuff. So they're less expensive and they're quicker. The best study that we've had done is we have a customer that has 140 diesel yard tractors. They had a third party company come in and do their own independent research, and the number that they came up with was a 2/3 maintenance cost reduction. And that was not only just with our vehicle, they had two other electric yard tractor OEMs there as well. So that's, for what they've seen so far, it's been true.
Great, thanks.
You're welcome. All right, we good to move on, Sarah? And just let me know if I'm taking too much time.
No, you are good. We still have about 30 minutes to go. I did see one of the two Natalie Van Dykes on the call did unmute themselves briefly. So if either of you had a question.
Yeah, and I do have a question quickly. I don't know if you address this later on, that would be fine, but I was very interested to see, I was looking at your specifications and I see that you have, the trucks are cooled. And I wanted to know if you have a battery thermal management loop on these, and if you do, is the battery thermal management, is it a separate loop than the air conditioning, or is it an integrated loop? And also, just because you mentioned grocery and HEB, You were talking about applications. Are any of those truck applications that you've done so far refrigerated trucks? So that's my.
Yep. So I'll answer your first question on how all of our trucks do have a battery management system. All the high voltage components are liquid cooled with coolant. Truck has a radiator, but the batteries are cooled from the HVAC, from the AC compressor. So especially when you're charging it, you'll hear the air conditioning and the fan kick on. So you just have ductwork that runs to both the battery packs to cool them. They're heated through internal resistance. As far as refrigerated, we do have several customers that have refrigerated trailers, and we run our trucks in those applications. I don't know if that answers that question on refrigerated or not.
It does. I appreciate it. Well, I'll talk to you more about it offline. It's kind of a nerd out thing. I won't hold up everybody else on it. Thanks.
I tend to nerd out on this kind of stuff too. So yeah, give me a call.
Okay.
So the first thing I think I'd call out on specifications is sometimes in the electric space with heavy duty or medium duty, there seems to be a lack of confidence in can this truck do the same work that the diesel does? And when you look at this vehicle, how it's spec'd with the amount of horsepower and torque it has, it's far superior to a diesel. Our truck has 315 horsepower and over 2,000 foot-pounds of torque. The comparative spec would be a Cummins 6.7 liter diesel engine. Those are going to be in the 220, maybe 250 range as far as horsepower. Max torque you can get on those is about 750. So obviously we don't have 2,000 available all the time. There still is a little bit of a torque curve like you do have on the diesels, but you can smoke the tires in this truck. It's completely possible. So any application where a diesel truck can perform, this truck will excel in that application. Some of the things I think that you all would probably be interested in is when we talk about the batteries. So our batteries, of course, are lithium ion, and then they're NMC chemistry, so they're nickel, manganese, cobalt. And I would say another kind of thing that's maybe a little bit of a myth is how long these vehicles are going to need to charge. That we may not be able to use them as much or put it up against the diesel in the same application where we need to run it, close to 20 hours a day. We can charge at 163 kilowatts. So we can charge even a battery pack that's 220 kilowatt hours. We can charge that in less than 2 hours. So when we go back to where I was talking earlier about, how many hours a day we're going to use it, when do we have opportunities to charge? We have customers that the only times they have that they can charge is when the driver gets out for a 30-minute lunch break. They have about 20 to 30 minutes in between shift change, and that's it. And they run 3 shifts. So we spec out a charger that's say 150 kilowatts or potentially 124 with dual port, that they can keep that truck running nonstop, and they don't have to just let it sit for 2 hours and let it charge, which really helps with the payback that we were talking about earlier. The other thing is with this vehicle, even though it is an off-road vehicle or considered off-road, it does have anti-lock brake system on it, and it also has traction control too, because especially in a wet yard or snowy yard or icy yard, safety is still a key piece and something that we certainly keep at the forefront when we manufacture these trucks, and that's why we made that standard on every vehicle we manufacture. This is a kind of an overview, and you'll see some of these parts in the next slide that I have. This is actually our S12. So this would be just one battery pack. So you'd have one battery pack that's mounted on the cab here in 2 steel enclosures. If we had our S22, which is the spec that I just showed you, you would have that on top of the cab, and then where this assembly is over here on the frame rail, you would have a second battery pack mounted on the frame rail, and these assemblies would move over to the space on this side. We would put them on the same side, but they just too heavy. So we just balance it out, one on the front right, one on the left frame rail to balance out the weight, because the packs are each about 1,800 pounds. All the components that we're running that are high voltage run through what we call the cradle. And I'll show you a picture what that looks like on the next slide. But just think about the cradle being, and specifically on the cradle, the high voltage junction box. Think about that replacing your diesel engine on how you power all those components that before are on diesel engines. So a perfect example, your AC compressor, for example, now is being powered through that power electronics cradle, which that's really its job. If you guys get the opportunity to see the truck, you'll see it's just all the orange high voltage cables going in and out of this one part in the cradle. The way we charge it, or where the charger's at, it's recessed in a thick steel bumper, and it's got a magnetic door on it that's probably about this big. And I'll talk more about charging on the next slide too. So the components or major components that go into this system, as I said before, all these are sourced through Dana, which, from being a prior fleet manager, having one point of contact for warranty, one software, one throat to strangle is what I always said, is a nice option. And it was also very nice too from an integration standpoint, to not have to work with multiple suppliers, to have one tier one supplier that we could have this full drivetrain. The first component there on the left is the Sumo MD traction motor. The Sumo series itself is highly commercialized and produced. There's been over 14,000 of those produced. So it's while it's new in our product, it's certainly not new, to the market. A lot of them are in buses in China. The middle piece there is what I mentioned, the cradle. So that's how we manage all of our high voltage components. We also house our onboard charger with our DC to DC converters. We also have two inverters. One regulates the current going to our hydraulic pump and motor. So on a normal truck, like a semi truck, the fifth wheel of how we connect up to a trailer is stationary. So when the driver connects to the trailer, he or she has to get out and crank the landing legs up on the trailer with a terminal tractor, yard tractor. They go under the trailer, connect to it, and then we have a joystick in the cab that they pull back. It lifts the fifth wheel up and it lifts the trailer up, so that driver doesn't have to get out and crank landing legs every time they have to move a trailer. And last but not least, we have the inverter that powers the traction motor. Even things like power steering are now powered, battery powered. So we have an electric power steering motor that's completely silent. That one actually does not run off high voltage. It runs off a 24-volt system. And then, of course, if we're going to have Dana components, we're going to have Dana axles. So we have the Dana drive series as well as steer axles. I'm going to kind of jump around a little bit on this slide because I want to talk first about charging. So there are some electric vehicle manufacturers. It's not as common anymore, but there are a few that, as far as charging protocol, are doing proprietary charging. All of our trucks are either J7 or it's a dual port that's J1772 and CCS1. So that plug that you see in the middle looks pretty similar to the one that we have in our vehicle. Customers that we talk to, they may purchase one of our vehicles, but in the future they're going to buy a box truck, which they would need to charge. They may buy a Freightliner eCascadia, semi truck. So they want a solution that they can spend the infrastructure, and these high capacity chargers are very expensive, So they want to be able to utilize those chargers on multiple OEMs and equipment types. So that's why we went with a standard, the North American standard for charging. We hit there on batteries. And then as far as range goes, the S22, that's 220 kilowatt hours that I showed the spec sheet for, it's up to 22 hours of operation before you have to charge it. I've seen it run more when we were doing, if you're familiar with the North American Council for Freight Efficiency, it's short for NACFE. We ran a truck for 18 days with Ryder, and based on the consumption rates they had, that truck would run for 30 to 31 hours straight before needing charged. Every truck also has telematics, so you can know where the vehicle is, but most importantly, you can remotely diagnose any issue over the air. We can have one of our guys in Texarkana log in and assist somebody on what's going on with the vehicle. And you can collect a lot of great data off the truck as far as how it's performing. This is my last slide, and then we'll open up to questions. So I have my email address in here. Be glad to talk about anything electrification, answer any questions you have. So with that, I'll stop sharing, Sarah, and if we have questions, we'll go there.
Awesome. Thanks, Chas. So we did have a couple come through when you were talking about charging. One of them is, how big is your onboard charger?
13.5 kilowatts. So it's a fairly slow charge. The only time that we typically utilize that is in cases where the fleet's only going to run maybe a single shift. Say they're going to operate the truck maybe 8 hours a day, and then even 10 or 12, and then they have 10 to 12 hours to charge it. We solely use that for the purposes of doing demonstrations. So that's one thing that we offer. Could be a 2-week, could be 1 month, it could be 6 months, depending on how long the fleet wants to test the truck. We have our own demo fleet of five vehicles, and I'm constantly moving them throughout the country. And we utilize that because it's a cheap alternative for those that don't have a DC fast charger. They can have a 240 volt outlet that's single phase and 60 amp. It pretty much looks exactly like the outlet at your home for your dryer. And then the truck would slow charge, but they can still get all that data from when they are operating it during the day.
Awesome. And then Andy Alden just asked, do you know if anyone is attempting to automate your trucks? And then do you use any drive-by-wire tech that would lend itself to automation?
We've had conversations with several different automation companies, folks that do drive-by-wire as well. To be completely honest, we haven't gotten past we haven't gotten to a place where I think we're going to have one soon. Never say never, but those conversations are happening. The hardest part with this application is figuring out how to get the airlines connected to the trailer and then disconnected from the trailer. Whoever can figure that out is going to win.
Awesome. That is great to hear. And I just want to go ahead. I scrolled back up in the chat and I noticed that there was a question from Andy Burnham, and you might have already addressed this. And if you did, I apologize for missing it. He asked, how long do you expect the batteries to last in the application? And if there's an expectation for replacement batteries?
Yep. So battery replacement, I would say in a fairly severe duty cycle, that's we haven't had any trucks out this long where I can tell you real world, but we have done lab testing with Dana and put it through severe duty cycle applications. And the expected life in that would be 8 years. We don't anticipate having to replace them. And typically in those kind of applications, they're going to be turning those trucks every 5 or 6 years. That's when they would be turning the diesel trucks every 5 to 6 years.
awesome. That is some great context. So yeah, since the chat seems to be slowing down, I'd like to welcome anyone to go ahead and unmute themselves if they have any questions. Chas put his phone number over in the chat, and I'm going to go ahead and put his email and my email if you guys have any questions for him, or if you have any questions for me about the series or the recording, please feel free to reach out to us.
So Chas, can I follow up on that question about the automation? You say it's because of the brakes for the trailers. And is that fundamentally because once you disconnect the air lines from a trailer, the brakes are locked, and that the only way you're going to get the trailer rolling again is to get air pressure to the trailer?
Correct.
Okay.
Yeah, so I think probably what's going to happen is on the automation side there, I think the vehicle can be automated, but then there's going to have to be work done with the trailer OEMs. And I think that's going to be where it's going to happen. I think it's going to be very, very complicated for someone to figure out how to put, say, a robotic arm on the back of the truck and connect and disconnect the airlines. I think it's going to be a technological advance in the trailers that they can operate with an autonomous vehicle and not have to have the airlines connected.
Maybe if they work towards braking by wire, that might be the way to go in the future.
Mm-hmm.
Because the way I think the brakes are designed the way they are now, where if you do lose air pressure, they fail to energized mode. So that that's one of the reasons why you see a lot of it's a safety issue, I think, the way they're designed currently. But if you move towards electrification, you might be able to achieve those same safety aims without having the trailer wheels locked all the time.
Mm-hmm.
Thanks.
Yep, you're welcome.
Awesome. Well, it looks like I don't see anyone unmuting themselves or raising their hands. So I think we might be able to give everyone back the last 10 minutes of their day. Chas, I want to thank you so much for joining us. It has been great to have you, and thank you everyone else for joining us and asking such great questions. This is exactly what we want this kind of session to be. I will be sending out the recording soon, and I'll also send out the presentation as well. But like we said, if you guys have any questions, feel free to reach out to us and we'd be happy to answer them. But otherwise, I hope everyone has a great rest of their week.
Thank you, Sarah, and thank you everybody for all the great questions. Have a great weekend.